This is Chapter 1 of the Electrician Program, Modern Residential Wiring 9th edition. That's the text by Holzman, Harvey N. Holzman. This is narrated and explained by Hector Vladimir. Chapter 1, Safety. The objectives include to understand the effects of electrical shock, to describe the conditions likely to affect the severity of electrical shock, to maintain safety during an installation, to list basic workplace safety rules, to explain lockout, tagout, and blockout program, and to describe steps for helping a shock victim. Some of the technical terms discussed in this chapter are arc flash, blackout device, electrical burn, insulated tools, lockout device, personal protective equipment or PPE, and tagout. Workplace injuries. The information in this chapter is designed to instill the knowledge that is required to work safely in residential wiring environment. This knowledge will boost your confidence so that you may do your job well without any fear of apprehension. However, be very careful about letting your confidence turn into complacency. Shortcuts around safe practices quickly become shortcuts to disaster. There are many types of injuries that may occur on the worksite. The obvious one is being electrical shock. The others include burns, eye wounds, punctures, cuts, and back injuries. There are many more. The effects of these injuries range from stopping an installation because a cut is needed to be bandaged, or to inflict grief onto family and friends because carelessness caused a death. There are situations that you can avoid if you learned about safety and safe methods, practice those methods, and repeat the practice until safety becomes a habit. Electrical shock. Electricity passing through a human body causes an electrical shock. The severity of a shock does not have much to do with the voltage as much with the amount of current. The shock of 10,000 volts is no more deadly than that of 120 volts. On the other hand, shock approaching 10 milliamperes or 0.01 amperes is painful and could cause severe injury. In Figure 1-1, the values and the bodily effects listed on the table are only an average. Conditions of body size, skin, moisture, and the amount of food and liquids in the body, surrounding humidity, and clothing change the severity of the shock. You will learn more about volts and amperes later in this text. For now, know that the electricity in most homes is far more than required to electrocute a person. Burn. There are two types of electricity-related burns that can occur. Both are life-threatening. The first is called an electrical burn, which occurs when electricity passes through the body. Just as wires heat up when too much electricity passes through, so will the human body. Often the victim has extensive internal damage and very little external indication of any injury. The second type of electricity-related burn is a result of an arc flash. Arc flash is the explosion that takes place when electricity short circuits through the air or across inadequate insulation. The temperatures during an arc flash are high enough to melt metal. An arc flash projects melted metal outward, injuring any unprotected workers in the area. The best way to prevent an arc flash is to de-energize the equipment before working on it. If this is not possible, be sure to wear the appropriate clothing and eye protection. Some definitions. Electrical burn is a burn that occurs when electricity passes through the body. Arc flash is an explosion that takes place when electricity short circuits through the air or across inadequate insulation. A first step in protecting yourself is to wear clothing that is made of flame-resistant fabrics while you're working on electrical equipment. Treating a burn involves removing the source of the heat and calling for medical help. Burns can be caused by electrical shock or arc flash, which are usually too severe to be treated by anyone other than a doctor or paramedic. While waiting for help to arrive, cool the burn with sterile gauze soaked in cool or not cold water. Do not apply ice to a burn, and never put butter, grease, or medical ointments on the burn. Be prepared to treat the person for shock. Caution: calling for emergency help. This is important to know where you are working and be able to describe the location of the work site if you have to call for emergency. Some work sites may not have a street address yet. Most will not have a telephone. If you call 911 from a cellular phone, the address will not appear at the dispatch center in most cases. Not all locations can receive cellular 911 calls. Be sure to know the number to call. It's not always 911 depending on your global location. Eye injury. An eye injury can be one of the most devastating wounds a person can receive and one of the easiest to prevent. Always wear your safety glasses whenever there is the slightest chance of an object being projected. You should also wear safety glasses when working in a position that causes you to look overhead. Dust and debris often fall from upper areas during construction. If any of this material falls on your eye, you may suffer an injury ranging from eye irritation to a scratched eye, or worse. There are many styles of safety glasses available to suit your needs and preferences. Some are shown in picture 1-2. And just as a side note, I was a lucky victim. I would consider myself of a near eye injury. Luckily, I had my safety glasses on. I was working as an electrician with EMT, or electrical metal tubing. In one of them, I was either cutting or doing some type of force to it, where it basically, I picked it up and it hit my face right in my eye area with such force that were I not to have my safety glasses on, I would have most likely either have a severe eye injury or at worst lost an eye. So I am myself a victim of that, and a lucky victim at that, because I was able to walk away from it just with some pain around my eye, but nothing else. And this was because I was wearing my personal protective equipment, my safety glasses. So always have them on. That was just one out of a few occasions where safety glasses basically protected me from severe injury and long-term, perhaps permanent injury. Puncture wounds. Puncture wounds will typically result from carelessness or sloppy housekeeping, using a file without a handle, for example, or pushing a chisel toward your body, or working around wood scraps with nails, which are all habits that can lead to a puncture wound. If you or a co-worker experience a puncture wound, the first step is to call for help. Always, if the object is still embedded in the victim, do not try to remove it. Instead, lay the victim down and stabilize the object. Removing it may cause further harm. If the victim remains standing or sitting, there is a chance of falling or fainting, which may cause additional injury. Cuts. Most cuts occur in the hands and arms. Sharp edges of electrical components and carelessness with cutting tools or picking them up are two of the many causes of cuts. When a cut occurs, You will need to clean and dress the wound quickly to prevent any infection. Wash the cut by running cool water over it. If the cut appears deep, you should see a doctor in case stitches are needed or infection may occur. Use an adhesive bandage to keep the cut clean and closed. Working safely. Being aware of the types of injuries that can occur on the work site is important. More important, however, is practicing safe work habits to prevent these injuries from occurring. In order to work safely, you must dress appropriately, use ladders and scaffolds correctly, operate tools safely, and practice safe work habits. Personal protective equipment, PPE. Personal protective equipment, or PPE, is the clothing and equipment you must wear in order to be protected from known hazards. This equipment may be the only barrier between you and 240 volts or more. There may be a few basic pieces of PPE. However, you should always wear these and have available at the very least. These include gloves, safety glasses, flame-resistant clothing, and a hard hat. See figure 1-3 on your screen. There may also be situations that require earplugs and a face shield and even more. When stopping or when shopping for PPE, purchase items that are certified by a national or a nationally recognized testing laboratory, or NRTL. Personal protective equipment, again, PPE is the clothing and equipment worn to provide protection from hazard. Ladders and scaffolding. There are many instances where you must use a ladder to get to a work area. Sometimes the work area will require an elevated platform, such as a scaffold. Never use a ladder or scaffold without proper supervision and training. Also review the manufacturer's instructions before using a ladder or scaffold. Both scaffolding and ladders should be handled carefully to prevent injury or property damage. Be particularly careful not to contact overhead wires or exposed wires. Falls from ladders and scaffolds account for a high percentage of work-related deaths. Ladders. Ladders are used by electricians and should be made of wood or fiberglass. Wood or fiberglass, such as the ones in figure 1-4. They should be set at a safe angle and tied off when necessary to prevent a slip or fall. As a rule of thumb, the horizontal distance from the base of the ladder to the structure should be 1/4 of the height where the ladder touches the structure. This is shown in figure 1-5. Make certain the base of the ladder has firm support. The ground or floor should be level. If it is not, use a ladder leveler to position the ladder safely, as shown in figure 1-6. Use extreme care if the surface is wet or icy. Special blocking may be needed to prevent slipping. Also, be aware of traffic moving around where the ladder is positioned. Step ladders should be set level. They must be fully opened so the hinges will lock. Never use a step ladder while it is leaning against a structure. Always open the ladder. Keep the joints tight so the ladder does not wobble or lean. When working on the ladder, always face it, such as in figure 1-7. Never use the top rung or step of any ladder for support. Check ladders often for step rot or other structural damage, and make sure to discard ladders that are in poor condition. Scaffolds. Wooden scaffolds are preferred to metal scaffolds for electrical work. If a metal scaffold must be used, it should be grounded. Handrails and toe boards should be secured to the top level. Lock all wheels if equipped to prevent unwanted movement. If you figured that one that shape, tie the scaffold off as well, especially if it is several platforms high. Always use a ladder to get onto the scaffold. Never climb the scaffold, or never climb the braces of the scaffold. Proper tool use. There are many tools available for you to use during your electrical training and your electrical career. You will use many of these in Chapter 3, Tools. When operated correctly, these tools, or these hand and power tools, can be very safe. As always, these are general guidelines to follow. Refer to the manufacturer's instructions always for full safe operation procedures of the tool. Power tools have made many jobs easier, but they have also introduced additional safety risks. Power cords and moving parts are two potential hazards. Be sure that the tool is switched to the off position before plugging it or plugging it in. Inspect the cords for damage regularly. If the insulation becomes damaged or the cord cut, do not splice it or wrap around it with electrical tape. This is not a proper repair. Install a new cord or maintain the original safety of the tool. Hand tools. Injuries commonly caused by hand tools include cuts and puncture wounds, among others. Improper use, especially of cutting tools, is a certain path to injury. Always remember to use hand tools in such manner that if the tool slips, it will not injure you or a co-worker. Insulated tools. You should always turn the power off before working on electrical equipment. This is the simplest preventive measure you can take to guard against electrical shock. There may be times when you will need to work on equipment with the power on. In these rare instances, you should use insulated tools and the proper PPE. Insulated tools have a non-conductive covering that prevents the transfer of electricity from the tool to the user. Or just because a tool has non-metallic coating or plastic handles, it does not mean that the tool will protect you from electrical shock. The tool must be identified as insulated tool that is capable of resisting a specific amount of electricity. Safe work methods. There are many tasks that you will do repeatedly throughout your electrical training and career. Choosing to apply safe work methods when performing these tasks will greatly reduce the chance of injury. This will allow you to continue to be a productive worker and to enjoy the life outside of work as well. Lifting and carrying. Improper lifting is a major cause of back injuries in the workplace. Bending over to pick up something up and twisting your back while lifting are sure ways to invite back pain. This pain can quickly escalate to the point where you may not be able to get out of bed, and that means a day of lost wages. To reduce the risk of back injury, always follow the basic rules of lifting shown in figure 1-10. Good housekeeping. Cleaning a work site may seem like the task that is reserved for the end of the day or even the end of the week. After all, it is during this cleanup time that many workers think about everything they have accomplished that day and all of the tasks they need to do the next day. However, It is during the workday that you should also be maintaining the area of work clean, tripping hazards, lost tools and materials, and general disorganization are all time-wasting consequences of working in a untidy area. Excavating. There are times when you will have to do work around another crew that is excavating, or you will have to dig into the earth yourself. Either situation will present a set of hazards. The first hazard is contacting an underground conductor or an underground conductor. Always notify the local utility before digging. They will mark the ground where any electric cable lines or gas lines or water pipe or television cable lines are buried. Do not use any powered excavating equipment within 24 inches of the utility markings, such as in figure 1-11. Second hazard when excavating is the possibility of a wall collapse. Any trench over 5 feet deep must be reinforced to prevent the sides from collapsing. There are various types of shoring designed to eliminate this hazard. Also, make sure to install barricades and warning signs around the trench. Without these warnings, other workers or passerbys may fall into the trench. Lockout, tagout, and blockout. One of the most important procedures designed to protect the electrician is the lockout, tagout, and blockout procedure. This is a combination of rules and devices that prevent the energizing of a circuit that could injure a worker. If an electrician flips a breaker to open a circuit and starts to work on that circuit, what would prevent another worker or person from resetting the breaker? Placing a strip of tape across the breaker or attaching a tag to it does not prevent the closing of the circuit. If the tape falls off, for example, or the tags are ignored, as a result, workers could get hurt or even killed. Always follow proper lockout, tagout, blockout procedures, whether working on residential, commercial, or industrial projects. See figure 1-12. A lockout device prevents the release of energy by attaching one or more locks to switches, breakers, valves for gas or liquid, and enclosures. The person working on the circuit is the only one with a key for that lock. If more than one person is working on the circuit, each is able to attach a lock on the device. Tagout. Tagout is the identification procedure that is used to let other workers know who applied the lockout. Your name should be on the tag so other workers know that you are working on the circuit. You may also include the dates and time of lockout, your phone number, when you expect to be done, and your company's name. All of this information is intended to improve the communication between workers. Write your name on a handful of tags and keep them in your toolbox. A tagout should never be used without a lockout or blockout. A blockout device is used to stop dangerous machinery if energy is accidentally applied. Opening a circuit does not mean all energy has been controlled. The power of a fan, for example, may be turned off and locked out, but if the fan blades have not been locked, there is still a possibility of injury. Air movement from another fan could cause the blades to move with enough force to cause injury. Also, switches have been known to fail and close a circuit. In this situation, a lockout device will not prevent the machinery or circuit from running, but a blockout device will. There are devices that are designed as blockout for specific equipment, but a board or pipe can be used if it is properly secured. Turn the power off. These 4 words will be repeated to you throughout this book and probably during your apprenticeship. Turn the power off. Never work on energized equipment unless it is absolutely necessary and you have the proper training, equipment, and PPE. Turning the power off will make more time than the actual work. It is not a reason to work on energized equipment. Replacing damaged equipment or making a trip to the hospital usually takes more time than turning the power off. I have insulated tools. It's also not a reason to work on energized equipment. Turn the power off and use the lockout, tagout, blockout methods to ensure that nobody else turns it back on. Responding to an accident. Since you may be the first person to respond to an accident, there are some basic procedures to know. This book is not intended to give you all of the information for aiding a victim. Instead, this is a brief overview of the techniques that could be applied. You are encouraged to enlist in a certified cardiopulmonary resuscitation or CPR and first aid program. The skills you learn in these programs may help you save a life or the life of a co-worker or even a family member. Helping a shock victim. If a co-worker is a victim of electric shock, tell someone to call for help while you start to assist the victim. Immediate action must be taken to help a shock victim. This is particularly true if the victim is still in contact with the source of electric current. If you cannot shut off the power immediately, remove the source of electric shock without touching the conductor or the victim. Use great care that you do not receive a shock yourself. After all, you will not be able to help the victim if you yourself become one victim. After the electricity has been removed and safely controlled, begin talking to the victim in a loud and clear voice. You want to see if the victim is conscious. If there is no response, try to keep the victim still while checking for signs of breathing. If the victim is not breathing, get someone who is trained to initiate CPR or perform it yourself if you are trained. Try to stay with the victim throughout the entire rescue and let the medical team take over when they arrive. Hazardous environments. All construction sites are to some degree hazardous environments. It is easy to look around these sites and see dangerous situations and be aware of them. As an electrical worker, you must also be aware of the invisible. The electricity within wires and electrical panels. When you step into this environment, you must be able to focus on the job at hand and be aware of the activity around you. Recognize the hazard. You cannot avoid or control a hazard if you do not know that it exists. Through training and experience, you will be able to recognize a hazard and take action. If you see a situation that you believe may be a hazard but are not sure, let your supervisor or co-worker know, or your instructor if you're in training. Overhead power lines can create one of the most hazardous situations. These lines are high voltage conductors that are often uninsulated and low to the ground. Carrying a metal ladder or conduit near these conductors should be done with extreme caution. If the equipment contacts the power lines, the electricity will flow through the equipment, through your body, and into the ground. Even if the equipment does not touch the power lines, it can come close enough to draw an arc. To reduce this risk, carry the equipment horizontally to avoid walking under the power lines. Improper installation, whether working on or working in new or existing construction, you may come across an installation that is not safe or it is not acceptable under local codes. The worst reaction to this situation is to ignore it. Doing so would put you and your coworkers and future homeowners at risk. Warn those in the area of the danger and immediately notify your supervisor or teacher. If the worker made the improper installation without knowing, a lesson was learned and the person is a better worker. If the improper installation was made because of carelessness or laziness, the supervisor or teacher knows to pay close attention to that person's work. Warn components. When working in older construction, you may come across outlets, light fixtures, switches, or wires that are worn to the point of being unsafe. Broken plastic, stripped screws, and brittle wire insulation are indications that these items need to be replaced. Do not try to reuse any components that are not in good mechanical or electrical condition. The cost of a new part is very small when compared to the possible costs of not replacing it. See Figure 1-13. Wet conditions. Often utility workers must repair power lines in the rain. Water is an excellent conductor of electricity, so special equipment and training are necessary to prepare them for these high-risk situations. Although you may not find yourself in a rainstorm, the rules of working in any wet conditions are the same. The first rule is to avoid it. If you're working on an entire house, work on the interior wiring on rainy days and install the service on a dry day. If you must work on wet conditions, make sure that you have the proper equipment and training to complete the job safely and turn the power off. The proper equipment includes a ground fault circuit interrupter for power tools, insulated tools, and PPE that is designed for these situations. See Figure 1-14. Fumes. This may not seem like to be a concern for electrical workers, but flammable fumes affect everybody on the work site. Always avoid allowing flammable fumes near any electrical equipment. A simple light switch can create a spark large enough to ignite the fumes. Non-flammable fumes, although not a fire hazard, can be just as dangerous. Gasoline-powered tools emit carbon monoxide, a colorless and odorless gas that can be deadly, especially when working in an unventilated area. Fumes from these tools can cause dizziness, headache, and illness. If you feel any of these symptoms, exit the building immediately and tell someone about your condition. I was myself almost a victim of this, and this can happen even in a outside or outdoors area. I was working with some vehicle wiring on a vehicle which I had on. The vehicle was running, and I was working on wiring on the rear of the vehicle where the tailpipe is, the exhaust pipe, and I was exposed to this carbon monoxide for a lengthy period, I would say over 30 minutes, and I suffered the dizziness, the headache, and the weakness of being exposed to this carbon monoxide to the point where I was pretty much poisoned and felt sick and dizzy again. And luckily I wasn't exposed to this long enough for any permanent damage to occur. However, being sick and being exposed to this poisonous gas will cause some damage. It is just a matter of how long and the concentration of this gas. Again, the longer the period, the worse, and if it's indoors, it's concentrated even more, and the damage could be even greater, to include death. Report the hazard. As stated earlier, you must report any hazardous situations. There are different methods of reporting the hazard, depending on the severity and the risk involved. You already know that if you do not come across, you already know what to do if you come across an improper installation. Notify your supervisor or teacher if you're in training. Other situations may only require you to notify your co-workers through tagout procedures. Barricades and warning tapes are effective tools to alert others of hazardous areas. The main purpose of all these methods is to let others know about the environment they are working in. Another technique is holding morning meetings to alert crews of an unusual hazard, such as an overhead crane lift that is scheduled for that day. Communication among all involved is the most effective tool against accidents. Repair the hazard. Correcting hazardous situations may be as simple as practicing good housekeeping or as involved as reworking an improper installation. Some hazards may not be able to be removed at all, such as overhead power lines. Removing this hazard involves notifying others in the area by speaking to them or erecting barricades. Review the hazard. Once a hazardous situation has been recognized, reported, and repaired, you should take time to review the preceding events on your own with your instructor or supervisor. The following are the questions to ask. Why did this happen? What are the chances that it will happen again? How can this be prevented from happening again? Was the appropriate action taken? Is this situation covered in the National Electrical Code or NEC? Reference: there are organizations that research, develop, and maintain rules, codes, and laws that are designed to promote safety. Some organizations are intended to make the workplace safe. Others are intended to make the final installation safe for the building's occupants. Some information regarding each organization will be presented in the chapter that relates to the organization's purpose. You should be aware of these organizations, and you may want to review their findings or even become a member. These organizations include OSHA, the Occupational Safety and Health Administration, the NFPA, the National Fire Protection Association, which is the publisher of the National Electrical Code or NEC, NIOSH, or the National Institute of Occupational Safety and Health, the ICC, the International Code Council, the IBEU, the International Brotherhood of Electrical Workers, the NECA, the National Electrical Contractors Association. And these are the review questions for the chapter. List 8 safety rules that an electrician ought to observe when working with electrical equipment and tools. 1 is to use PPE. 2 is to use equipment in good condition and appropriate for the job, such as ladders and scaffolding. 3, use appropriate tools that are in good condition. 4, use sane work methods or safe work methods, such as lifting and carrying, housekeeping, excavating, lockout, tagout, and turning power off. Always recognize and report hazards. Know how to provide aid to shock victims and how to prevent shock. 7, repair hazards. Do not ignore them. And 8, avoid and know how to work in hazardous environments. Question 2. True or false, an aluminum ladder should not be used when working around electrical wiring. That is true. Aluminum is a metal and it is highly conductive. You should avoid using aluminum ladders when working around electricity. True or false, lockout procedures apply to only one industrial and commercial work. That is false. It applies to all types of work. Amount of current passing through the body, that's question 4, is an important factor to remember in electrical shock. A current approaching how many amps is painful and possibly severe, and possibly has severe effects, and severe effects will be experienced. And this is as little as 10 milliamps or 0.01 amps. To aid a victim of electrical shock, list all of the following you should not do and explain why. And the answer for this one is A. Quickly grasp the victim and drag him or her away from the current carrying material. You should not do this because this may transfer the shock to the helper. Number 6, wearing personal protective equipment during a blank will help to prevent burns to the skin and the eyes. Fill in the blank. That would be an arc. Know the code. Question 1, what is an authority having jurisdiction? That would be an authority such as a city inspector or county inspector or a state or federal inspector that has been certified by the state, by the city or municipality to carry out inspections and to enforce municipal, city, or local laws or regulations or code that pertain to electrical work. Number 2, what is meant by informational note and what is it? An informational note may be a communication written in written form to other workers to warn them of a certain condition, usually a hazardous condition. Number 3, what does the term listed mean? The term listed means that a piece of equipment or a technology has been inspected and tested by a testing laboratory or a testing authority which is certified or recognized to to very reliably test for defects or safety problems or safety shortcomings with a certain product, technology, equipment that is electrical or is to be used for electrical purposes such as an electrical panel, a certain tool, or even a piece of equipment such as a circuit breaker or a toaster for that matter. And that wraps up Chapter 1 of the Electrician Program. Again, the text and material by the book Modern Residential Wiring 9th edition by Holzman. This has been a program narrated and edited and explained by Hector Vladimir. Thank you very much. Look for the second chapter of this program.